All right. Good evening, folks. Good evening. I guess we are live here. Just gonna have one quick check with AV. Is everything good? I guess you're able to hear me, see me. Are we good with the AV here? Just gonna wait for a couple of minutes. Yes, I guess we are all good. Nice, nice, nice. Right, great. So once again, yeah, good evening, everyone. We might have to probably continue from where we left. Last class we have discussed about number classification. We spoke about factors. We spoke about prime factorization, number of factors, product of sum of factors, product of factors. We did one round of all of that. Now we'll probably jump into something called your HCF and LCM. I'm going to talk about, this is something that you have been doing from your middle school, even your primary school. I think you start doing HCF and LCM in your 4th, 5th grades, and then you amp it up. We do a lot of things, but have one visit about HCF and LCM for this class. That's going to be the agenda. I'm going to wrap it up with only HCF and LCM. We have one bunch of things. Sometimes you don't get a standalone question on HCF and LCM, but then the idea is being used in other places as well. So I think it is slightly essential that you have one grasp around it. So we'll do that. Just in case you guys have missed out your fundamentals batch, you can go enroll it over here. Go check out the website, go over there, enroll it. You get all the options, you get your DPPs, you get unlimited playback, you get all the stuff. Check out on the website, have a look at it and see if it works for you. Jump in, enroll. Right, we'll talk about it. I'll give you a reminder once again. So quickly, what is HCF? I'm pretty sure some of you studied it as HCF, some of you probably studied it as GCD, greatest common divisor. Some people call it highest common factor. What is the difference between HCF and LCM, and what are the benefits? What are the type of questions that you can get? So we'll jump out. So HCF, once again, highest common factor. I have to write F, that's the rule. Or you call it GCD, which is greatest common divisor. And then you have LCM, least common multiple. The key lies in the two words that we see here, multiple factor. So highest common factor. So what is the one number that is, which is a factor of the maximum number of numbers that you see? Can you tell me the one number which is a factor of the most number of numbers, the maximum number of numbers? Can you tell me? Athar, did we study 8th to 10th LCM and HCF? Was it that late? I remember doing it in my 7th grade, man. 6th, 7th grade. Exactly, Ria has gotten it right. 1 is the number which is a factor of how many numbers? All the numbers in the system. We call 1 happens to be called a universal factor. One is called as a universal factor. 1 is the factor of every known number, every known natural number. So 1 is the factor. It is common to all the numbers. But is it the highest common factor for all the numbers? No. It depends on the numbers that we are looking at. To take an example, let's say 8 and 4. I want to find the HCF and LCM of 8 and 12. So how do we do it? Let's look at 8. The factors of 8 happens to be 1, 2, 4, 8. For the factors of 12, we happen to have 1, 2, 3, 4, 6, 12. No prizes for guessing. 1 is there. 1 is a factor. 2 is a common factor. 4 is a common factor. We happen to have a lot of common factors, but of the lot, which is highest, 4 is called as the HCF. Right? Simple game, nothing fancy. What about the LCM then? Now when I say LCM, again for 8 and 12, what do you mean by LCM? Multiple, not just any multiple, common multiple, not just any common multiple. We are looking at the least common multiple, which means simply we have to write down all the multiples of both the numbers given over here and then look at the number that is the least, right? So if I say 8, then the next multiple will be 16, then 24, then 32 and so on. The multiples of 12 happens to be 12, 24, 36, 48 and so on. The first multiple that is common between both numbers is 24. So my LCM is 24, HCM is, right? Simple idea, nothing fancy. This is how you do it. This is how we have been doing it all our life. But 8 and 12 happen to be simple numbers, convenient numbers. How about numbers that are big? Let's say if I am talking about, let's take 36 and then 48. Just to give you some two numbers, convenient numbers, but then still 36 and 48. What is the HCF of 36 and the LCM of 36, 48? HCF of 36, 48, LCM of 36, 48. Now we did this in school. I like this idea of, again, prime factorization, very specifically L method, right? We did this. What is the HCF and LCM of 36 and 48? If you remember, for 36 and 48, we used to do the LCM part this way. You remember this? You divided by 2, 18, 24, 2, 9, 12. Again you do it by 2, 9, 6. Again you divide it by 2, 9, 3, because 9 doesn't get divided by 2. And then you divide it by 3, 3, 1. Again you divide it by 3, 1, 1. So LCM is equal to 2 into 2 into 2 into 2 into 3 into 3. Right? This is how you did it. So which is 2, 2, 2, 2 is 16 into 9. That's how we did it. Right? In case if you have missed out, forgotten this, there's a conventional way of finding the LCM. How about the HCF? You write the prime factorization of both numbers. Not writing HCF, just writing. For 36, you can write it as 2 into 2 into 3 into 3. For 48, you can write 2 into 2, 2, 2, 3, right? And how many ever numbers are common, you take them alone. So HCF is equal to 2 into 2 into 3, which is 12. LCM, there is a way to do it here. Whatever is again left out, we take that part alone. Now here you can take this 2 and 2 again. You again have 2 into 2 into 2, that is common, into 3. You take this 2 again. You take this 2 again. Take this 3 again. And then you get it. This is what you did in school and it works for your school time. I like this. You go to the basic of any number. That's the conventional way of doing it. Sometimes when you don't have the numbers, you get variables. That's how you do it. First you take out all the commons and then whatever is being left out, you take that part alone. That's how you do it. There are 3 numbers. Any 2 numbers that have a common number, you take that. Any prime number that's common, you take that. This is how you did it. But eventually when you grow, when you prepare, you should have some mechanism to do it more conveniently. I'm not telling you this is a shortcut, but sometimes this works. In my head, I will simply list out the multiples of 48 and then see which number gets divided by 36. 48 doesn't go in 36, 96 doesn't go in 36, then another 48 is 144, goes well in 36, so LCM is 144. And you should be comfortable doing 44 table now. If the number gets a little bigger, we are not comfortable doing it. So there has to be some mechanism to do it. I follow one technique. HCF again, you'll have to do it conventionally to get used to it. You have to understand the factors component, what are the factors, how to prime factorize a number, that works. But LCM, what I'm going to do is, I want to give you one nice idea and then say, if it is 36 and 48, LCM of 36 and 48, right? All you can simply do is, whatever ratio it is in, write it in the simplest form. Whatever two numbers that you get, write it in the simplest form. The two numbers that you get, simply take the simplest form. So both of them go well in 12. So this is 3:4. Simply either multiply this or multiply this. So get your LCM. 36 into 4, 144. 48 into 3, 144. That is your LCM. If you know how to find your HCF, you can find your LCM. Simple. Nothing fancy. But again, your questions are not going to be of this format. There are going to be layers to it. There are going to be some ideas plugged to it, and we'll have to find out how it's done, right? So rather than giving you a theoretical part, we'll solve one question of each type to understand the HCF LCM concepts, right? Any doubts? I want to have one quick look at the chat to see if there are any questions. Yeah, I think I'm just getting all the answers here. So I think we are good. We'll jump and then get to the questions. We'll start solving them. So I want you to find the HCF and LCM of the three given questions over here. Have a go at it. I'll give you 3 minutes, one question each, 1 minute each question. Go for it, attack. And there is some idea that I'm following here. I'll also tell you that. We'll do the three questions over here. Simple ones. Simple ones. Nice and easy. So we'll have one look at it. First question says 24 and 48. Now, sometimes when you look at two numbers, two or three given numbers, if we'll talk about three numbers gradually. If one number is a factor of the other number, what will be the HCF? Look at these two numbers, 24, 48. What will be the largest number that can divide both 24 and 48? Now we notice that 24 is a factor of 48 itself, right? So it has to be HCF is equal to 24. What about LCM? Now, if one number is a factor of the other number, it means that the larger number is a multiple of both the numbers. So LCM is equal to 48. If one number is a factor of the other number, HCF is the smallest number, LCM is the largest number. Simple. Nothing tricky over here. You just have to plug in and then get it done. I want to add one more question to this. 17,39. We'll come to this later. Next one, 40,32. In case if you have finished these three, have a look at this. Simple one. I'll just finish off and then I'll come there. So 40,32. So 40 and 32. So I want to simplify this to the smallest form in ratios. Both of them go, the largest number that can divide both the number is 8. So I'll straight away say, hey, HCF is equal to 8. But what is my LCM? Now, if you are not comfortable doing the table part, the ratio parts will work. If you cancel it out in 8, what do you get? I don't want to strike it off. Sorry. Simplify this. This is 5:4. Just multiply this. 40 into 4 is 160. 40 into 4 is 160. So LCM is 160, HCF is 6. Simple. Look at 18 and 27. Once again, both numbers HCF. Easy. As simple as it goes. It's 9. Nothing fancy. LCM. What is my LCM? So if I cancel it out in 9, 18, 27, the ratio becomes 2:3. So 18 into 3 or 27 into 2, either ways it is 50. Nothing tricky here. You look at the last one, 17 and 39. I notice that both of them are primes. Both of them are primes, which means they don't have any factors except one. So what will be the HCF? Straight away, HCF is equal to 1. They don't have any factors in common. HCF is 1. What will be the LCM? Now 17, none of the multiples of 17 matches with 39. The only place where it happens is when it is 17 into 39. Or think about this, 17, 39. I can cancel it out in only one, so which will become 17 and 39. Multiply this, that is 17 into 39. I want to look at 17 into 39. 17 into 40 is 680. 680, 670, 663. And that is your answer. Right? Any doubts? Any questions? Before I jump to the next part, I want you to look at all these numbers over here. I'll show you. 24 and 48. HCF is 24, LCM is 48. Right? The numbers HCF and LCM. Right? I want to write it in this format for all the numbers. Check it out. 40 and 32. HCF is 8, LCM is 160. 18 and 27. 18, 27. HCF is 9, LCM is 54. 17 and 39 is what I had. 17, 39. HCF is 1, LCM is 17 into 39, which is 616. I want to give you one easy number so that we can see if there is a connection. 4 and 8. I want to take one more. 4, 6. I'll take 4 and 6. So 4, 6. HCF is 2, 2 is a number that divides both the numbers, that's the largest number. LCM is 12 goes well. Now I've written the two numbers. I've also written the HCF and LCM. I'll give you a minute or two and I want you to spot if there is a connection between the two numbers and the HCF and LCM. See if there is anything that you can connect. Have a deep look at it. See if there is a connection that you can build. Anything that you can think of? Someone has spotted it. First statement, brilliant, brilliant. Now, if you notice, if you slightly look into this, 24 into 48 is equal to 24 into 48. Check this out. Check this out over here. 40 into 32 is equal to 8 into 160. Right? Check this out over here. If you notice, 18 into 27 is equal to 9 into 54. You will realize that it is happening all the way. 17 into 39 is equal to 1 into 663. 4 into 6 is equal to 2 into 12. They happen to be equal in all cases. From here, we infer the fact that HCF into LCM of the two numbers is equal to product of the two numbers. That's the property that we use in a lot of instances, right? That is the idea behind the property. HCF into LCM of the two numbers is equal to product of the two numbers. And very powerful. Sometimes it helps you. A lot of questions, pure HCF and LCM questions, you might probably get this, and this is utterly important. So get a note of it. Same thing is in professor. Which one? I am not sure which one you are asking, Athar. Right? So get a grasp of this and note this is applicable only for two numbers. For three numbers, it might not work. I'll tell you why. If I give you an example like 10, 20, 30, HCF is equal to HCF of the three numbers is 10, LCM is 60, 10 into 20 into 30 is 6000, this is only 600. So it might not work every time. So make a note. That's why I've very clearly written HCF into HCM, HCF into LCM of the two numbers is equal to product of the two numbers. Make a note, it works, right? HCF into LCM, all these numbers, exactly, works for all the numbers. It works for all the numbers, Athar. Check it out. 40 into 32, 8 into 16, they both will be same. They both work, right? Now, if you have understood this part, go for this, solve the question. Aishwarya is asking which method is used for 2, 3, 4 numbers. We don't have a definitive property for more than 2 numbers. You don't have a foolproof statement saying that a product will work with the product of the other 2 numbers. We don't have anything as such. It is applicable only for 2 numbers. Now this should be easy, right? Since you have already run through the theory part here. HCF and LCM of 2 numbers are 12 and 180 respectively. One number is 36. Find the other number. Simple. So 36 is one of my numbers. Into my other number, I'm going to call it n is equal to 12 into 180. So n is equal to 12 into 180 divided by 36. I'm going to cancel this 3 times. Cancel this 60 times. N is equal to 60. Nothing tricky, nothing fancy. Straight, pure idea. Plug in the property, we are through. Right? We'll hop on to the next question now. This one's not tough. But moving forward slightly, there is going to be one hidden point everywhere and we are going to crack it. For example, look at this question. Read the question thoroughly and then answer. Once again, I'll give you a minute or 2 for you to read, understand and then solve, and then we'll attack. Right. So the question says, find the greatest number that divides 101, 157 and 213, leaving the remainder 5 in each case. Now, we are not looking at numbers that will perfectly divide a number. It is telling me, hey, 101, 157 and 213 are 3 numbers that gets divided by a certain number, and I am looking at the largest possible number that would do it, but it should not divide all the 3 numbers. It should give you a remainder 5 in each case, which means that there is a certain number called, let's call n, 101 divided by n, there is a remainder of 5. Or I can say 96 is perfectly divisible, right? I'll read it as 96 is absolutely divisible by this number. Similarly, if I say 157 divided by n, the remainder is 5 again, or I can say 152 is perfectly divisible. Similarly, 213 by n, I get a remainder of 5 again, which means 208 is perfectly divisible. Or I can say 96, 152, 208 is divisible by one large number, and I'm looking at the greatest possible such number which will do that. Or in simple words, we are looking at HCF of 96, 152, 208. That's it. We're looking at some number which is a factor of 96, 152 and 208. What would be that number? Pull out your techniques, see what number works. I look at 96, look at 152 and 208. I can think about the factors of 96. 96 is 2 to the power 2 power 5 into 3, which is 32 into 3. You can, if you are not still comfortable thinking about numbers, do it the conventional way, write it down in the simplest form. 2 power 5 into 3, sorry, for 96. Is equal to 2 power 5 into 3. 152 is equal to 152 goes well in 76 into 2. 76 is 38. Again 38 is 19 into 2. So I'm looking at 2 power 3 into 19 power 1. 208 goes well in 8 for me. 8, it would be 41 times. So that is 2 power 3 into 41. Not 41, sorry. Oh shit. 25, 26, 2 power 4. My bad. 2 power 4. Oops. Yeah. Give me a minute. My bad. So that is 2 to the power 4 goes well in 16. 192, 208. Yes. 192 2 power 4 works. 16 is 10, 12, 13. Am I right? Yes. 13 to the power 1. Am I looking at the right number here? 130 and 78. Yes. 2 power 4 into 13 to the power 1. Now from each of them, what is the largest power of 2 that I can take? 2 power 3, 2 power 4, 2 power 5. Simply looking at HCF is equal to 8. This part is something that we already have. The math is the part which we already know. But if I look at a question like this, which says largest number that divides x comma y comma z, if I have to put it simply, largest number that divides x comma y comma z, leaving r as remainder. If the question goes something like this, find the largest number that can divide x, y, z, leaving the same remainder r in each case, we are simply going to find HCF of x minus r, comma y minus r, comma z minus r. Nothing tricky. Simply remove the remainder from the given 3 numbers, find the HCF of those 3 numbers, and we are done. Right? This is a generic form for this part. You don't have to memorize it as formula. Go to the logical idea. Okay, 5 is a remainder. I divide it and then I get 5 as a remainder, which means I can remove that 5, the number gets perfectly divided by this number n. So that way you can think rather than memorizing it as a formula. But for some people, they want to have notes, they have clean notes of every idea. If you fall under that category, you can use this. This is a generic form. I prefer this, more logical. Right? We'll jump to the next one now. Same question, same type. But there is a slight difference here. So there's one catch with this question. Read it, try solving it. Exactly. Atharva and Ray are asking same remainder in each case, but what is the remainder? Ray is asking, do we take R in this case? Yes, we do. The question is, what is R? I don't know what it is, right? So if I ask you this question now, let me put it this way. If I say there is a number called 7 and then there is a number called let's say 15, 7 and 15, I am giving you two numbers, 7 and 15. I want you to tell me what is a number that will divide both 7 and 15 leaving the same remainder. Give me one number that will divide 7 and 15 leaving you the same remainder. I am not telling you what number, I am not telling you largest number and all. Give me one number that will work. Ria, perfect. 1 does, right? 7 gets divided by 1, remainder 0. 15 gets divided by 1, remainder 0. So clearly telling me that, hey, 1 works. Is there any other number that will work? Is there any other number in your head that you think, hey, 7 and 15 can be divided by this number, and on both occasions I will get the same remainder? Swastik says 1 and 2. Brilliant. 2 works, right? 2 works. 7 by 2 remainder is 1. 15 by 2 is also remainder 1. But I am going to ask you one more time. Is there any other number that will work? Is there any other number that will work? Check for some other number. Is it only 1 and 2 or do we have any other number? I've gotten 1, I've gotten 2. I want you to find and tell me if there is any other number. Yes, Ria says yes. What is the other number? Swastik says he thinks 4 works. Let's see if 4 works. 7 by 4, remainder 3. 1 times 4, remainder 3. 15 by 4, 12 goes off, remainder 3. Hey, Swastik, I also think 4 works. Or I'll give it to you, 4 works. I'll do it one more time. Is there any other number that you think will work here? Is there any other number that you think, hey, 7 and 15 can be divided by this number and it will give me the same remainder in both cases? This is one more number that I am thinking of. Sorry. Others say 7 and 15 are natural numbers. Yes, they are. I want you to think of one more number and tell me, hey, this number also satisfies this condition. 1 did, 2 did, 4 did. Is there any other number that we are thinking about? Anything else? 7 and 15, no. You divide 7 by 7, remainder is 0. You divide 15 by 7, remainder is 1. You have to divide both numbers by the same number. Not a different number on both occasions. Athar, no. You can't take 7 and 15. You divide 7 by 7, remainder is 0. 15 by 7, remainder is 1. 7 by 15, remainder is 7. 15 by 15, remainder is 0. You can't do that. One more number works. One more number. One other number. No, Ria, you are telling me the LCM. I am looking at HCF. You are dividing 7 and 15. You are dividing 7 by a number, 15 by a number. So you are looking at factors, not any other numbers. Very specifically to this question, it is not factors. You don't call it factors here because you are leaving out a remainder. If you notice, 8 also works. 8 by 7 cannot divide it, remainder is 7 itself. 15 by 8, sorry, 7 by 8, remainder 7. 15 by 8, 8 goes off, remainder 7. In both occasions here, when you divide it by 1, remainder is 0. When you divide it by 2, remainder is 1. Divided by 4, remainder is 3. divided by 8, remainder is 7. Right? Riya says getting confused now. Which part is confusing? All these numbers will work. You can divide 7 and 15 by 1, you will get the same remainder. Divided by 2, you will get the same remainder. Divided by 4, you will get the same remainder. Divided by 8, you will get the same remainder. Right? That's what you are looking at. I want you to list out all the numbers here. I have listed out all the numbers. I dare you, I challenge you, you cannot find any more numbers than this. There are no other numbers that will satisfy this condition. Divide 7 and 15 by each of these numbers. This will be the corresponding remainders. Every time it will be same on both occasions. Right? Any doubts, Riya? Are we good here? You said you got confused. I think we are good here. Now comes the question, which is the largest number? This is the largest number, 8. Had I given you 7 and 15, you would have said 8 is the answer, right? You would have said 8 is the answer. But I cannot keep doing this, right? I cannot keep thinking of one case at a time. Now, if you didn't do this, look at the two numbers here and tell me, is there a simpler way to do it? Is there a simpler way to do it? How 8? To this question, the largest number is 8, right? Oops. To this question, largest number is 8, isn't it? According to this question, 7 and 15, I am not solving this yet. We haven't touched this yet. We are doing this example scenario. Yes? Done. But if I had given you only 7 and 15, is there a nice simple way that you could have done it? Can you do it? The answer is yes. What do I do? Simply take the difference. And what is the difference between 7 and 15? 8. Not HCF. I cannot call it HCF because once again, it is not divisible. Largest number that divides 7 and 15 is 8, leaving the same remainder. Sir, how can 8 give the same remainder? Re-up, divide 7 by 8. 7 divided by 8, 0 times 0, the remainder is 7. The remainder is 7. 15 by 8, 1 time 8, remainder is 7. I am getting the same remainder in both cases, Riya. That's right. Clear? Are we good here, folks? I'm looking at the largest number that will divide both the numbers and give you the same remainder. That's what we are doing. Right? So simply take the difference, look at the difference, and then say, hey, that is the largest number that would have done it. That is the largest number that would have satisfied the given condition. For two numbers, this is fine. For any two numbers, the difference between the two numbers is the largest number that will divide the number, leaving out the same remainder. Leaving out the same remainder. For any two given numbers, take 16 and 24. What is the largest number that would have divided both the numbers, leaving out the same remainder? Check this out. Difference is 8. And that's the largest number. Since the remainder is 0, since in this condition the remainder would be 0, we call it HCF. Take 23, 41. 23, 41. What is the largest number that will divide both the numbers, leaving out the same remainder? Simply take the difference. What is the difference between 23 and 41? 18. That's the largest number. 23 by 18, remainder 5. 41 by 18, 36 goes off, remainder 5. Take the difference of the two numbers. That is the largest number that will satisfy the given condition. Simple idea. Are we good here? Any doubts? Are we good here? But if I come to this question now, I'm going to rub this all part. If I come to this question now, there is 143, there is 213, there is 38. I said there are two numbers, take the difference, it's the largest number. There are three numbers here. What will I do? Do the same thing. What is the difference between 143 and 213? 70. What is the difference between 143 and 318? What is the difference between 143 and 38? Sorry, not 318. 38. 62 over here, 43 over here. 62 and 43 would give you 105. What is the difference between these two numbers? Not necessary, just find any two difference, that is enough. But just to be on the safe side, just to make you understand, what is the difference between these two numbers? 175. Now, the difference between 143 and 213 is 70. Difference between 143 and 38 is 105. Simply take HCF of 70, 105, or HCF of 175, 105, 70, 175, it doesn't matter. Any two difference, take them, find the HCF. HCF of 70 and 105 goes well in 35. Once again, let me correct myself. You cannot call it HCF. Largest number that divides all these three numbers, leaving out the same remainder is 35. 38 divided by 35, remainder is 3. 38 divided by 35 is 35 plus 3. 143 can be written as 140 plus 3. 140 is divisible. 213 is 210 plus 3 because 210 is divisible. 35 is the largest number that can divide all the three numbers, leaving you the same remainder. If I have to pen it down in a simple definitive format, largest number that divides x comma y comma z, leaving the same remainder. But I didn't tell you what remainder it is. All you do is HCF of x minus y comma y minus z. Any two numbers. I would rather say, rather than x minus y, take the difference. Difference of xy, difference of yz, or y minus z, x minus y. Any combination of two differences, take them. Find the HCF of those two numbers, you have your answer. That will be the largest number, right? Any doubts? Are we good with this now? Simple idea again. I'm breaking it down to a definition. You simply take difference and then you say that's the HCF. Stop there. But then I'm going one step further. I'm giving it as a definition. You don't have to memorize this. Look at the question, read it, understand what it says, and then you travel with it. Right? Any doubts? Are we good with this, folks, now? Shall we hop on to the next one? Go for this. Same idea, something different. Attack this. In case of LCM questions of this one, find the smallest number which when divided by 18, 24 and 30 leaves a remainder of 7 in each case. Now they are telling me, hey, give me a number that is divisible by 18, 24 and 30. The number should be divisible by 18, the number should be divisible by 24, the number should be divisible by 30. But it should give you a remainder of 7 in each case, which means there is a number which is 7 more than which is divisible by 18, 7 more than a number which is divisible by 24, 7 more than a number which is divisible by 30. Or in simple words, we can break this down and say, hey, all I am doing is LCM of 18, 24, 30 is the smallest number that will be divisible by these three numbers, but I need an extra remainder of 7, right? I'm giving it a 7, right? Simple. If I tell you, give me the smallest number that is divisible by 4 and 6, and it should give you a remainder of 1, which means when I divide it by 4, I should get a remainder 1. If I divide it by 6, I should get a remainder 1. And I'm looking at the smallest such number. What would that be? 13. How do I know that's 13? 12 is divisible by 4, gives me a remainder 1. 12 is divisible by 16, 12 is divisible by 6, remainder is 1 again for 13. So I am simply taking LCM of 4, 6, adding 1 to it, because I said smallest remainder as 1, right? Smallest number with the remainder 1. I would have done this. I am doing the same logic over here, plugging in the LCM, find the LCM and then add 7 to it. We are through. So what would be the LCM? 120 goes well in 30, also in 24, but doesn't go in 80, there has to be a 9. So that is 360. LCM of these three numbers is 360 plus 7. We are looking at 367, and that is the number that will satisfy the given condition. 360 by 18, remainder will be 7. 367 by 18, remainder is 7. 367 by 24, remainder is 7. 367 by 30, remainder is 7, and that is the first such number where it happens, right? Any doubts? Are we good here? 4301. Ria has gone to 4301. I don't understand. Maybe she got stuck somewhere. You subtracted 7. Oh, you subtracted 7 from each case. You have to be utterly cautious about what you are doing. The question is LCM, not HCF. Clear? Are we good? Ria has gotten it wrong. I think you got it right now. Yes, great. Now if once again, if you want me to write it down, smallest number which when divided by x, y, z leaves a remainder of, let's say, small r. LCM of x, y, z plus r. That's a simple, again, a definition, not a definition, a formulaic way of saying that whatever you have done, I have written it in a formula, right? Look at this question. This has a nice idea to it. I'll give you once again 2 minutes, run through the question and then I'll discuss. Right. Find the smallest number which when divided by 9 leaves a remainder 5, and when divided by 4 leaves a when divided by 5 leaves a remainder 1. They are telling me there is some number I divided by 9, it gives me a remainder of 5. I divide that same number by 5, it gives me a remainder of 1. And they are asking me, hey, what is the smallest such number that we are looking at here? I'm thinking about this, and then I realize, had that been the same remainder like the previous question, the remainder was 7 in each case. Divided by 18, remainder 7. Divided by 24, remainder 7. Divided by 30, remainder 7. It was a common remainder in all the cases. But if I look at this question now, it says, hey, by 9 the remainder is 5. By 5 the remainder is 1. And then I'm like, okay, what is one such number that will work? I noticed that in case the standard way of thinking about this is, there is some multiple of 9. I'm going to call it some, let's call this number called some p. Now think about this, there is a number called p. Now let's assume that, let's take it for granted that p is divisible by 9. There's a number that is p that is divisible by 9, but the number is not perfectly divisible by 9, it leaves a remainder 5, right? P would have been divisible by 9 perfectly, or for us to understand this, let's say this number is of the form 9x plus 5, there's a perfect multiple of 9, and then plus 5 to it is what we are looking at. This number n is equal to this. When divided by 9, the remainder would be 5. Some number, I don't know what number. Why 9x? Because it is divisible by 9, this part. Add 5 to it, it won't be divisible anymore. The same number, can I say it is of the form 5y plus 1? Can we say, hey, it is also 5y plus 1, right? But very interesting part is, now this number leaves a remainder 1 when divided by 5. Can we say, had this number had another 4 to it, this number is perfectly divisible by 5, because this would have become, let me take a lighter red, this is the lighter red, I'll take green then, I'll take green. Plus 4, this number would have become 5y plus 5, or 5 into y plus 1, which is absolutely divisible by 5. Would have worked if I had added another 4. If you look very closely, if you add 4 here again, this number is also perfectly divisible by 9. Or can I say, the number that we are looking at is 4 less than perfectly divisible by 9 and 5. Can I say this? If the number had another 4 to it, this number would have been divisible by 9, this number would have been divisible by 5, or in simple words we can say LCM of 9, 5 minus 4. I will talk about what this minus 4 is, we will talk about what 4 is. There is a term that is being given to this 4 here. We will talk about what this idea is. But then can we come to this conclusion? Find the LCM of 9 and 5, take that number, remove 4 from it, that is the number we are looking at. Check this out, LCM of 9, 5, write 9 LCM again. Can I say this is 45 minus 4, 41. This can be written as 36 plus 5, or I can write it as 40 plus 1. When divided by 9, remainder is 5. When divided by 5, remainder is 1. So what is the number that we are looking at? We call it 41. This term 4 has a name to it. We'll talk about that later, but for now this is the idea that you need to know. Any doubts? Adhav says 41, Swastik 41, Praveen 41, brilliant. I'm getting all the answers. We are in the right track. If you have gotten the answer right, you are doing good. Any doubts, folks? Any questions? Jump on to the next one. Beautiful question. Beautiful question. There is one catch to this, so that's why I chose these numbers. Go for it. Yes, sir, this is the second last question. We just have one more after this. You cannot pick the highest common multiple. Praveen is asking, for lowest we take LCM. There is nothing called highest common multiple. Highest common multiple of any two numbers is infinity, right? Highest common lowest common factor is always 1. For any number, the least common factor is always 1. For any two numbers, highest common multiple is infinity. You cannot find it out. You cannot get that question in the first place. Kanak says 3, Riya says 3, Atharv says 3. I'm not sure if it is 3. We'll go to it. Sum of two numbers is 630 and their HCF is 45. We are looking at two numbers whose sum is 630 and the HCF is 45. How many such pairs exist? Now, since I know the HCF of the two numbers is 45, can we say the two numbers are 45A and 45B? Why 45A and 45B? 45 into some number is the first number, 45 into some number is the second number. Both numbers should have 45 as the HCF, which means both numbers are divisible by 45. So, I am taking 45A and 45B. Sum of these two numbers, 45, I want to go with 45A plus 45B is equal to 630. 45, I take it out common, A plus B is equal to 630, or A plus B is equal to 630 divided by 45. 45 into 2 is 90, 90 into 7 is 630, so 2 into 7, 14. A plus B is equal to 14. Which means I am looking at two numbers A and B, where A and B should be natural numbers, because you put 0 here won't work. So I know that A and B are natural numbers. Sum of A and B should be 14. So what are the possible combinations that you can make for A and B? A plus B. What are the cases that we can take? What are the scenarios that we can take? A and B. We are calling it A and B. They are not necessarily in that name. The order doesn't matter to us. I'll tell you what it means. But A plus B equal to 14. Right? Now, shall we write a few cases that we get? I can easily take 1, 13, 2 and 12, 3, 11, 4, 10, 5, 9, 6, 8, 7, 7. Do we have any other numbers that will work? Not really. So I am taking all of this. So shall we say 1, 2, 3, 4, 5, 6, 7. There are 7 different pairs that will work. There are 7 different pairs that will work. Can we say that? Kanak, Ria, Athar, you all are telling 3. I have 7. So who is right? Is it you or me? I have 7 pairs here. But you are telling me 3. Kanak and Athar was saying 13, 11 and 9. 13, 11 and... What about the others? Why can't I take 4, 10, 2, 12, 7, 7? Ria says I am right. No. The ones who said 3 pairs are right. Why? Now, there is one important idea that you probably should be thinking of. I'll tell you what it is. Now, if I say, just to give you an understanding, if I take A, B to be 7, 7, what is 45A? 45 into 7. What is 45B? 45 into 7. This is 315. This is 315. What is the HCF of 315, 315? What is the HCF of 315, 315? 315. But the HCF clearly says is 45. Can this be a case? But can I keep doing this every time? I cannot be taking cases every scenario. But I understand one idea. The moment I say two numbers of the form 45A, 45B, HCF is equal to 45. The very important idea is A, B are co-primes. There are no other factors common between A, B. No factor should be common between A, B. Why? The moment there is something common between A, B, that is no more, 45 is no more the HCF. We will take an example. If I take 18, then let's say 54 and then 45. This is 9 into 2. This is 9 into 6. This is 9 into 5. Notice this. Except 9, the other numbers cannot have anything in common. 2, 6, 5, what do they have in common? 1 is the only factor. When I say HCF is equal to H, two numbers will become HX, HY. X, Y are said to be co-primes. To give you a recall, what are co-primes? Two numbers are said to be co-primes when the highest common factor, co-primes, HCF is equal to 1. Two numbers are said to be co-primes when the highest common factor between the two numbers or three numbers, the given numbers, is 1. This is a super important property that you need to know. On that ground, I will eliminate every case that is not co-prime. 1, 13 works? Yes. 2, 12? No. 4, 10? No. 6, 8, no. 7, 7, no. So how many pairs will work? 3, 11, 5, 9, 1, 13. So how many pairs? How many pairs will exist? 3 pairs. Clear? Any doubts you found? Connect says confidence low kar diya aapne. Sometimes I like messing up with people's heads. You have to be very certain. I understand that when we are not certain of something, even when we go in the right path, we have doubts. I tell people sometimes even when you are wrong, even when you are right or wrong, it doesn't matter. Be firm with what you think of. I can twist your head. Don't let me influence you. Do not let me influence your mind. Do not let me influence your thought process. Make mistakes. I rather tell people it is okay if I confuse you. It is okay I put your confidence down. You will say, hey, I got this right. I don't want to let someone impact my thought process. Go wrong and tell yourself, hey, I did a mistake, but someone corrected me. I tell people, make mistakes today, not on November 29th. That's a process. I like messing up with people's minds. I love doing it. I'll instill doubts in your mind and I want you to think of it. That's the key. Ria says, I found multiples of 45. Yeah, no, it's just a fluke, Ria. It is just a fluke. You happen to get it. You probably happen to get it. Multiples of 45, again there's 6 different cases. You don't get those pairs, no. You took pairs that make 45. No, we are looking at two numbers whose sum is 630 and those two numbers have a HCF of 45. Right? Are we good here? We'll jump on to the last question for the day. Hit this. We are done. This one's easy. Riya's asking, can you show another example question for question 7? I'll do it after this question. Yeah, I can give you another example. We'll do that. We'll do this now. The product of two numbers is 360. How many of the following could be the HCF and LCM of the two numbers? So I've been given the product of the two numbers. They're asking which could be the HCF and LCM. We know that product of two numbers is equal to HCF into LCM. The product of the two numbers is given as 360. So 360 is equal to HCF into LCM. I just have to think, I just have to look at the options and then say which option works. HCF is 6, LCM is 60, product is 360. This seems to work. We'll hang on. 4 into 90, 360. 9 into 40 is 360 again. 12 into 30 is 360. How many of the following could be the HCF and LCM? Hey, all 4 of them are working. All 4 of them. I'm worried. Which one? Maybe all 4 of them. If there's a theta question, will you say all 4 of them will work? That's what you'll think about, because product is equal to HCF and LCM and all 4 of them are working. The question is how many of the following could be, which means all 4 could be a scenario. In case if your mind says, hey, all 4 of them are right, then unfortunately you are wrong. It doesn't happen. I solved question 8, it's look like chess. This is wrong. Why is it wrong? To explain this question, go back to question number 1. I think I have this beautifully put over here. Or is that in the theory part? Okay, I'll go. Yeah, here it is. Now look at the HCF and LCM in each case and see if there is anything that you look at, if there is anything that you spot. Other says 4 my answer is a theta question. If you say 4, let's see if it is right. Look at the HCF and LCM. HCF is 24, LCM is 48. HCF is 8, LCM is 160. HCF is 9, LCM is 54. HCF is 1, LCM is 663. HCF is 2, LCM is 12. See if there is anything that we spot here, any correlation between the HCF and LCM. Check this out. Tell me. Look at this, all cases. HCF is a factor of LCM no matter what. No matter what. For any case, sorry, I'll write it in. HCF is a factor of LCM. Always. Always. 24 divides 48. 8 divides 160. 9 divides 54. 1 divides 663. 2 divides 12. For any set of numbers, irrespective of how many numbers I am looking at, HCF of some numbers is always a factor of LCM of those numbers. Right? It has to be there, right? It has to work. You come here, we'll explain it with an example, not an example. Check this out. If I take some numbers A comma B, LCM, let's call it L, HCF, let's call it H, just to give you an understanding. LCM is a number, L gets divided by A comma B. Check this out. H divides A comma B. Notice this. H can divide both A and B. Both A and B can divide L. Clearly I know that H will divide L, right? The HCF of any set of numbers is always a factor of LCM. Now from here I can clearly say HCF divides LCM perfectly. Clear? On that ground, I also have to ensure that the HCF is a factor of LCM. If my HCF cannot divide by LCM, then I am not looking at the right option. 6 divides 60, yes, works. 4 divides 90, no, and that's not my option. 9 divides 40, no. 12 divides 30, no. How many of these pairs will work? Only one pair. Clear? Are we good here? Be cautious. You have to understand that not only you just don't stick with one idea. Product of two numbers is equal to HCF and LCM. You don't stop there. I have to probably add a layer. That is the layer. For any set of numbers, the HCF of any set of numbers is a factor of the LCM of those numbers. If there are 3 numbers, the HCF of the 3 numbers is a factor of the LCM of the 3 numbers. For 10 numbers, the HCF of the 10 numbers is a factor of the LCM of the 10 numbers. It doesn't matter. So you don't stop with one idea, you add layers, right? Any doubts? Any questions? It's a simple idea. HCF and LCM, but there's quite a lot to it. Co-primes, reminders, a bunch of ideas. It also leads you to some other concepts which we'll talk down the line. Are we good here, folks? Done. Then we'll stop here. We'll have one look at the remaining set of ideas in the forthcoming classes. Just in case if you have missed out in the first part of the class, check for the fundamentals batch in the website, enroll to it. It's there under the batches part. You have it called CAT Fundamentals 2026. And let me clarify it very clearly. This entire batch, CAT Fundamentals 2026 English batch, will happen only in English, no other languages. It happens in English and English only, right? Are we good here? We'll stop here. That's it for the day. In case if you haven't joined the groups yet, those are the QR codes. That one is the group that I run. I have it. Any doubts, any questions, anything relevant to our class, you will see it over here. And that is the MBA Wallah English medium batch. So group, Telegram group. Join the groups in case if you haven't. We are done with the class. We are good to go. Thank you. Thank you. Thank you.